Welcome to Justin Tutorials. In this video, we are going to derive the Nerst equation. This equation is very important when it comes to bioenergetics. So before we do that, let's prove some terms, some of these equations here. First, we're going to prove that delta G is equal to delta G standard. Delta G gives energy, gives free energy, and as a equilibrium, it is represented as delta G standard. So let's prove that delta G is equal to delta G standard. First, let's bring a fundamental equation. Fundamental equation here is delta G equal to delta G standard plus RT ln Q. The arrow is a gas constant and the T is the absolute temperature. Ln Q, the Q is a quotient, which is the product all over the reactant. And let's go on. Now, Q, we have product all over the reactant. Is equal to 0. When the product is equal to the reactants, you have 0 as the answer. Therefore, RT ln Q is equal to 0. So let's substitute this let's substitute RT ln Q into the fundamental equation. We have it that delta G is equal to delta G standard. Since RT ln Q is equal to 0, it will be plus 0, and 0 means nothing. So what is left here is delta G is equal to delta G standard. That means it is true that delta G is equal to delta G standard. So also we are going to show that delta G standard is equal to minus RT. Now we are going to show that delta G standard is equal to minus RT ln K equilibrium. So let's bring back our fundamental equation. Delta G equal to delta G standard plus RT ln Q. At equilibrium, delta G is equal to 0. And delta Q is equal to Q equilibrium or K equilibrium. So let's substitute this into the fundamental equation. That means 0 equal to delta G standard plus RT ln Q. Since Q equal to K, it will be 0 equal to delta G standard plus RT ln K equilibrium. So taking delta G standard to the right hand side, it will be delta G standard equal to minus RT ln Kerr equilibrium. So now let's derive the Nerst equation. So the first equation that we have here is delta G is equal to NFE. Let's call this equation 1. Delta G, I said earlier, that is the Gibbs free energy. The N is the number of electron transformed, and the F is the Faraday's constant, and E is the electrical cell. Now, what are we going to do next? Let's also bring a fundamental equation, which is delta G is equal to delta G standard plus RT ln Q, and delta G standard is equal to minus RT ln Kerr equilibrium. So therefore, delta G, let's call this one equation 2, let's call this equation 3, and delta G equal to RT ln Q minus RT ln Kerr. Let's substitute equation 1 and 2. By substituting equation 1 and 2. So we are having minus NFE. I know you might be tempted to ask why the minus. When NFE comes to the right hand side, it will take a why the negative sign rather. When NFE comes to the right hand side, it carries a negative sign. So it minus NFE equal to RT ln Q minus RT ln Kerr. Now let's divide both sides by minus NF minus NF, and minus NF will cancel minus NF. What is left here is E equal to RT ln Q all over minus NF minus RT ln Kerr all over minus NF, and E is equal to E standard at equilibrium, and E standard is equal to RT ln Kerr all over minus NF. So therefore, E equal to E standard minus RT ln Q all over NF, and this is the Nerst equation. Thank you for listening. Do well to